じゃあちょっと日本語と英語とミクチャーで、いや、その最近エージェンシーっていう言葉がA ライフの分野では結構どうやって定義するかっていうのが議論されてます。なのでちょっとその話をしたいなと思います。So what I'm going to talk about, what is the agency, right? So without defining agency, that we cannot go forward because, usually the people think it's very trivial to define agency, but it's not so easy. So I try to discuss new concept, which is what I call a collective agency. It's one of the main theme. So back in I don't remember it's 2015 or something when I got a postdoc from UK. His name is Martin Beale, and we discussed a lot about how the agency emerges from the universe. That's what we have to discuss. So we wrote a paper. This is toward information-based spatial temporal patterns as a fundamental for agent representation in dynamical systems. And this is, for example, like you guys know this the Game of Life, right? 動かないからいいや。So usually these are the gliders. The glider is moving around, right? So if you notice that which one is a glider, and then he thinks that the glider is like a minimal agent, and still he's been studying this, how to define glider as an agent, right? But there are some missing properties when I see glider. Comparing with the biological agency and then artificial agency, right? So that's what I'm going to discuss. But the glider, identifying glider is very important because once you notify that this is glider, then you can compress the images, heavily, right? Because if you don't understand the glider or agent, then you really have to do it like from randomly. It's the beginning, right? But once you notice the glider, then you know how does it move. And then so that you can identify, here's the glider, position A and B and C, then you can compress. But that's another thing. But anyway, so I said that glider is very important. And then recently, this kind of story has been made a big progress. And this is something that I like. In Japanese, we call hataraku saibo. So I saw this one on airplane, and so it was very interesting. It's quite funny, right? And white cells and black cells, they have its own agency, right? So then they try to move around and they make a entire body, or you can call entire immune system, is protected by each, cognitive element, right? So that once when you see this movie, then you see that your body is a society of agents, right? And then also in the movie, of course, those white blood cells and seems to have a cognitive memory and decision making and everything. So so in our field, in artificial life, that we try to say, so what is the agency? And then these are it's kind of my personal definition of it because I haven't have any, sort of consistent definition with my colleagues still. But first of all, I think it should be autonomous. And autonomy is one of my big criterion when I come to define agency, right? It's able to maintain and regulate itself, not just pushed around by the environment. But that, I think, is the original definition of agency, I think. But then it should be goal-directed. Goal-directed is it has its own purpose, right? Have to go this way or other way, but it's decided by itself, right? So act in a way that tend to achieve outcomes, then purpose-like behavior, even without conscious intent. Right, but consciousness is a C word. It's very difficult.
Can I just ask one question?
Of course. Can I go to the third one?
Of course.
But third one is something like it's a third one is for me it's very important, right? Usually that people think that physics law is a deterministic, right? So either deterministic or completely stochastic. But usually that people think, underneath of this stochastic behavior, it's always deterministic, right? However, once we try to understand what life is, then we probably have to have like a partial differential equations, but partially, it's not a deterministic, but it's more like undeterministic. And then the question is whether that's possible or not. So it's not completely deterministic, but it's partially deterministic. And that's what we have to model the living systems. Yes, and the question is?
Sorry, so because we are playing around with AI agents,
Oh, yes.
and I feel like now these agents have some kind of agency, especially with the Claude Code that I'm playing around with. It's AI decides what to do. It kind of is, if I try to connect with another service through an MCP and it fails, it proposes, but we don't worry, we have this AI APIs that we can try, and then continuously proposes something. So do you call that an agency or?
Yeah, of course. So that's what I was so shocked when Grisha gave a talk last week in our lab, right? Then I had the same feeling when he was started to talk about, because I was so surprised when I did the cloud code and cloud agents and everything. It's so autonomous and so goal directed, and then it's very adaptive, right? They can change, the strategies and everything. So already artificial life is there.
Can we take a brief survey from the audience? Who has experienced this feeling with the agent systems that they use? That feeling that there is something, in terms of autonomy and goal-directedness, some other beast has emerged that maybe in the past 2 months, maybe 3 months. Yeah, we have one person. Yeah, I mean, I know you. Who else has experienced this with their agents yet? It's quite interesting. Yeah, so I would say a minority of the population in this room have experienced this feeling. And that just goes to show how few people have access to the real power of these systems. Mm-hmm. Because a lot of this stuff is really expensive. I started spending $200 a month on this. Now I'm basically spending thousands of dollars a month on this. And it is quite insane. My colleague Fiza, she saw me at the very beginning of this, and I was kind of crazy. I was in such a parallel mode. And there's something maybe to be said of, am I being dopamine hacked by these systems to feel like I am hyper productive and I can produce so much code that functions that my attention is just completely washed into all these different directions? That's the reason why I think the world is ending. Because as a software developer, I no longer know how to deal with this emotion because I'm being hacked by these agents. So it's the agency is almost inverted in some of those. Yeah, so I'm wondering, what are your thoughts on the relationship between two agents?
Yeah, well, actually, so these days I'm watching Winter Olympic Games, right? And then there's air skiers, right? So usually the people, what we mean by the skiing, right, is a slalom, or in Japanese, daikaiten. It's carving a lot, right? But what people are now watching, is quite popular right now, is air, right? How many times that you can rotate in this way, and then also to the horizontal way, right? But the usual, normal skiers cannot do this, right? But that's the same thing is happening in science. The rules are changing right now. The people can do very good at slalom, cannot do this airs, right? And then also the physicists, computer scientists, trained in different way, how to coding and how to teach programming and physics, that you have equations and you simulate in a computer. Those are the different rules that what the people are going to do, right? Because we have this coding agents, right? The cloud code, it's a different thing, right? You really don't have to code anything. You don't really have to write out equations or anything. They're just gonna do whatever you want to do, right? So starting from there, that even if you don't know anything about Lagrangian or anything, right? You can simulate anything, right? So that's something the rules of the the sports rules are different right now. So what I'm gonna do with this? That's my honest feeling. だからルールが変わっちゃったっ ってことなんです。でそれはすごく怖いことで、今までやってきた科学のルールと全然違うものが今から走るから、だから昔の競技で金メダル取った人も今回やったら入選しませんよね。でそれはもう明らかにそうで、じゃあどうしたらいいんだって。So what I'm gonna do this? That's a big question to me. Yeah.
So is that what you want to talk about? I just want to make sure that we go through all the slides.
Oh, no. これはもうなんか最後の生き残りの科学のテーマとしてやってることをやってる。
Did you want to say? Yeah. Oh, well, thank you. I agree with your feeling, especially when you have what you said, like that boundary between deterministic and stochastic, and when you have this total agency where you don't have control. And as you said, we're talking about ourselves, and then we just deployed like for 25,000 developers, like this kind of tools. So imagine your fear multiplied by 25,000. So then you say, okay, are these 25,000 people really being productive, or is this getting out of control? So then our approach has been to simplify this agency. So we're trying to be really strict on the goal that each component has. So in fractalizing each component by very simple rules, we start to get a little bit more deterministic. And so it gives us a little bit more peace of mind and in our wallets as well. But that is, of course, then you have to share the fear, the philosophical fear, and then me as an investor and as a company, of course, the monetary expense and the human expense as well. So that is just something, if you are trying to see, Professor, in terms of where are we going to this agency, should we try to limit that agency into something more specific or not?
Yeah, well, it's a difficult question still, but there's some other thing that I wanted to. Can I add something? Because that's okay. Because then my very good friend, he passed away 10 years ago, but Shusaku Arakawa, he's an artist, right? And then we've been discussing a lot about everybody can be a scientist and artist, and that's going to be the ideal world, right? And then now it's possible, right? When I went to art university a few weeks ago, then she did a very beautiful pieces without knowing how to code anything, right? And also, maybe scientists using those, cloud coding that you can have a beautiful, images on screen without knowing how to present your ideas and things, right? Because the cloud code help you to do everything, right? And this morning, because we implemented like open cloud in our computer, right? So that I asked him, okay, I wanna, buy cameras and sensors, and can you see this room? And after a few hours, and he said, okay, here's your room, look like, and that's what he did, without telling anything him, right? But I told him that it just connected the monitors and sensors to the computer, which is Raspberry, and then he did install by himself. What's the driver and it is necessary, and then connected with his computer, and then his monitor is coming up, right? So that you can see this the room by touching anybody, right? So this is one of the reasons that I was so much impressed with it. Nobody is going to teach how to program in a class, right? Because it's so obvious, it's so absurd how to teach programming to students, because students already know. Well, they don't have to know coding, right? But they know how to interact with the cloud. That's the only thing that they have to know, right? Yeah, that's I was so depressed when he was saying this, and because I had the same feeling, what the Grisha was. Sorry. Then what was your question?
If we have to start thinking about limiting the agency of these tools into really specific, because as you said, if that is the philosophical thing, students should only train about discernment. Right?
Well, I think why I came up with this agency is because concept is the only thing that we have to come up with. If you have a good concept, right, then it's ready instantiate your concept in one way or other, right? So that the very big thing that you have to do is come up with very good concept or ideas. Right? That's why I think it's still there's a
So
place
coming
to
up with new ideas is like the new bar for agency. It's kind of like
Maybe,
if you can generate new ideas and if you can sort of, I guess we discussed this a little bit,
Yeah.
you know, what scientific taste is like
Yeah.
or artistic taste. You know, these kinds of things, if you can tune those skills, which are much more less objective function definable, then those skills will be safe, you know, from these kinds of automatable futures. And so, you know, yeah, potentially that's sort of what
Well,
you're suggesting.
Yeah, well, I'm suggesting that we are in the same the member of the same society, right? So usually that people think that AI is a tool, but we do have to think that AI as an agent, like your friends, your parents, your friends, right? So that both of us, I mean, AIs and humankind, right, working together to make a symbiont society, and I'm pretty much sure that from there is a what I call collective agency is emerging on top of it, and that's what I'm very much expecting to accelerate our culture and science in a good way. Well, of course, it's very problematic how to define a good direction of this agency, but yeah.
So I think to your question, I think he's suggesting we should not reduce the agency of AI agents, but try to make it.
Yeah, but the question is, how to define it. That's why I'm saying this. So how to define agency is still a big problem.
I
right?
see.
Yep.
So I've been blown away and been playing with these tools as well myself, and blown away. But maybe this is being partially a psychologist in me that's sort of like, are they really an agent, right? And so I'm sort of curious what you think in terms of, is goal directed? Well, we gave it the goals, right, to a large extent, or it's inferring what those goals are. So how important is it that they're sort of self-generated goals based on needs, right, and these kinds of concepts?
What do you think?
Oh, me? So there's
like, for example, the goal is in general that we have to give everything to agents. But when I'm like open close, but I only know the close right now, working with it. But I don't have to give them everything, right?
Yeah, I think this question reminds me a little bit of one of the papers that the VC of Google brought out recently. It's called Agents as a Society of Mind or something like that. And he's one of the supporters of the A-Life Institute as well, and he loves what we're doing. And so one of the things that's stuck out to me from that paper is that every agent is actually a society of personas that are constantly debating each other to emerge to the surface. And when you're prompting the agent with some goals, specific language, what you're doing really is you're bringing out one of those personas, or maybe a couple of them, to the surface. Do you want the agents to behave like a mathematician? Think like a mathematician. Do you want him to behave like an analyst, a financial person, a lawyer? You have to say it, and suddenly that persona emerges from the sea of personas. And I think that's where it's a little bit weird to think about, because our agency is contained within one persona. And then this is why I'm interested in your concept of collective agency, because as a society, we are a society of personas.
Yeah.
And so we have a society of personas within one artifact in this case. And so maybe there's a similarity to be drawn of when a politician kind of, gives a specific message, society then brings out a specific persona in response to this message. And it can be powerful, it can be dangerous, it can be...
I think that's good. So that now that I can go to the next page. Because that's exactly what I'm going to talk about. Yeah. So so I said this, and then for example, like instead of Android, I'm working with a collective of ants and a collective of honeybees and then a collective of tetrahymena. Then right now that we can tracking every individual, right? So that the data is gigantic, but then we can calculate what sort of friendship personality, and then what kind of personality is emerging, and this kind of thing that basically that we can do, because but also that we don't go into the internal structure, internal state, if that exists, that we cannot do this. But from the superficial point of view, I mean, like how they move around and how they interact with each other, that's possible to get all these detailed data set, right? So so I was so like this, using a UNet, which is one of the kind of deep neural network, that we can track everything, right? We can identify all these individuals and we can track. Yeah, these are the ants. Yeah, if you have never seen this. So I think agency.
If you've never seen an ant, you need to go outside and touch.
Yeah. Right. So to me, agency is like autonomy plus goal directedness plus history dependence. Then even a single cell can qualify because it can carry information across time, right? So what I'm saying is even a single cell can be an agent, right? Because they have autonomy and they have a goal directedness and they have like a history dependency, and these are I think it's a necessary condition for having agency in a very unique basic level. So the tetrahymena that I was using is a tetrahymena is like a big bag, right? Within the bag there's a chemistry is going on there, right? That's a simple-minded physicist's idea that there's a bag and put the chemistry inside and then probably it becomes a
I think as opposed to the ant, I think not many people know what a tetrahymena looks like. Could you briefly explain?
Well, the tetrahymena is like this, tetrahymena is this, right? It's a tetrahymena ってゾウリムシみたいなもんなんだけど、it's like a kind of protozoa, right? So that they.
I'm a little bit troubled by this.
本当はね。
Sorry for that.
Disconnect.
Is it disconnect? I don't know.
Sorry.
So this is usually you can detect and then you can identify which one is moving in this way or that way, right? So that's possible. So but different from a protozoa, the protozoa is only self-dividing like 60 times or to 50 times, but tetrahymena can do it infinite times. So in that sense, that they never die, right? But the protozoa, as far as I know, it's limited by 60 or 50. And then also it inherits. So that why I started to work with those little creatures is that because I noticed that there is a interesting inheritance that exists.
Can I jump in for a sec? I like this addition which you have carrying information across time.
Yes.
I think this is something that all of our AI agents at the moment cannot do.
Yeah, that's right.
We have to shoehorn that in. And, you can add it as an extra functionality, but it's very easy to just like go, okay, I'm going to wipe your memory now. And you are not going to exist anymore. Goodbye. And spawn a new one. It's like your ancestors performed poorly. Be better. At least if you're me, I'm a bit of a dictator when it comes to.
Well, you can be the god, right? God to the society.
But actually, like maybe let's talk a little bit about how you think about carrying. What's the necessary requirements to be able to carry information into the future?
Yeah, well, it's something like for us, we know that neural network that can carry information, right? Neural network the pattern that exists, but also the chemistry and chemical turbulence that also have the memory, right? So there are a bunch of different kinds of memory, not only neural network memory, but in physics, there are lots of memory that usually the people call it hysteresis that exists. But the problem is how to access to the memory is another thing, right? So storing is okay, but how to access to the memory to use it is another thing. But then, we did this. But then, so usually that people say the protozoal tetrahymena is just a Brownian motion, random walking, right? So that it's not so interesting. However, when I plotted energy distribution of this, it's a bit technical, but it's usually that we expect that is an exponential distribution function.
If it's following the Brownian.
Yeah, if it follows that Brownian motion. But it looks like it's a different because it's a long scale. And then if it's exponential, that should be the straight line. But it shows like curvature, towards the origin of this graph. And then this one, the first generation to the second generation, the same pattern is inherited to the next generation, right? Well, 似てるじゃん. It's very similar, right? And then third one is also quite similar, right? But
changing.
Yeah, it's a little bit changing. And then fourth one is some of them, it's not so much, similar to the first one. But again, I tried so that I tested a different individual. But again, you see, some of them are so that I think this tetrahymena individual has a sort of memory. But this one is about the kinetic energy, means that its motion behavior has some memory, right? But how they can, transfer to the offspring is a big problem. And then I still don't know why. But so,
how many generations do you think humans remember?
Oh, that's a very good question. No, at that time I don't know, but maybe it's do you know this? If you have like 8, what? 孫ってなんていうんだっけ? 8 grandsons, then you have to compare with your how many kids that you have. Then there is the relationship between this and this, right? Oh. I'm sorry, I have to answer to this very correctly because I teach this. But because this is evolutionary biology tells us that how many kids, and then if you increase more grandsons, then it's you can be more cooperative with others, and so that at least 3 generations that there is some sort of inheritance. However, this one is a DNA. Usually, the people think inheritance is always, carried by the DNA, right? And then the besides the DNA, there is some epigenetic effects, right? And then epigenesis is something, but I don't know how many generations that epigenesis is possible. But usually, the people can say that if you change the environment, then yep.
Yeah, so epigenesis and the environment and memory and context in these multi-agent systems and LLMs, I think it's like one thing that I've noticed is that it seems like memory and what's remembered is very tied to current context in terms of what's useful. And, this is just an analogy, but I think that in our daily lives, even like myself, what I remember about myself in my own life changes depending on the kind of person that I want to be, right? So I think about that with the context of LLMs, and depending on, maybe we don't want them to remember everything, because like if it was a mistake, or if I'm genuinely making design decisions that I'm telling it to do it, it's doing all the right things, and then I decide, oh, actually I've changed my mind, I don't want that feature anymore, make it go away. I want it to forget. And that's an important thing. So, but when I'm hard coding that into a multi-agent framework or a system, how does that get reflected? And I've been thinking a lot about the environment as an external scratch pad, a memory, like a buffer. And I see that all around us, like as humans is what we're doing, like our histories. What we choose to remember between generations is, in one part determined by the kind of materials that we take and the time that we take. But on another hand, it's also determined by where we're at as a society, what we choose to remember, because it has a big reflection on what we want to do with
That's
that
very
information.
interesting. Yeah.
I actually think it's very wise to look at it from the perspective of who do we want to become, because we will remember the things that are useful to us. It reminds me a little bit of the problem of how a lot of techniques are being lost because there's going to be an inheritance crisis. A lot of shokunin, a lot of like traditional crafts, all that knowledge is gone.
But what do you think? I mean, do you think LLM agents can inherit something once they want to make a copy? But once you make a copy, that the code will be transferred, maybe. But it's a behavior. I don't know.
Yeah,
right?
I mean, it's funny because to some extent, maybe if I understand Alyssa's point correctly, is that we get to choose how we allow those rules to some extent we get to choose. But at the same time, we've already observed an instance where because of the next round of training of these models will train on a version of the internet with already these models inside it. So it's a form of environmental memory buffer.
That's right.
Where so you cannot avoid a certain kind of inheritance. And it's funny, there's like a lot of, I think at the beginning of this year, the CEO of Anthropic released a essay about how actually it would be quite ironic if there's a subset of personas within the LLM which actually inherited information about all the sci-fi novels where the humans get overtaken by robots, and then we just end up upmodulating that at some point at the wrong point in society, and it'll actually, because we wrote about this, because it's in our history, it gets inherited and then actioned, and that's kind of would be ironic.
I had to explain that once the first one is divided into 2 to 4 to 8, so that's gradually making a society, right? So that the society also taking over what kind of thing that should be inherited and what kind of behavior should be. That's the next story, right? So that exactly what I was thinking, that information is, as I said, inheritance is information that survives time and constrains the future. But what happens when the memory is no longer inside one cell, like you said, so that distributed across many cells, surroundings. That's something that I was interested in. Like so that it's always like when I was a student, still that people have been discussing this. But in Japanese we call nenkin, the slime mold, and people. So it's slime mold, and I didn't see any progress in this field, but but that's not true. They are going into the RNA analysis and everything, but but it's a collective agency is coming. When I was looking at this, and then when a group becomes an agent, because the predictive and the controlling power shifts from individual to the collective systems. So that's what I wanted to understand. What happens, how this shift happens, and how you can quantify this. So that's what. And do you know this? 対バンってなんていうのかな。なんてね。対バン。ね、対バンってなんて。プラセンタ。So the placenta 日本語で言うと対バンなんだけど。Can I explain first of all in Japanese?
Yes. And if there's questions from the Japanese audience, please.
最初に子供が生まれる時僕びっくりしたんだけど、子供ってこの卵子から精子と卵子からこう受精卵ができて、受精卵から子供ができるんだけど、同じように胎盤もできて、みんな胎盤になりたくないじゃん。この間研究室で聞いたらみんな誰も胎盤になりたくない。いやだって胎盤ってさ、お母さんからの栄養を渡すけども自分は生き残らないじゃない。で中の子供はさ、成長するわけでしょ。そう胎盤はそれで流されて終わりじゃない最後に。どっちになりたい？胎盤と中の子。胎盤っていうべきですかね。いやだから胎盤になりたくないでしょ。だからみんなもこの人たちもみんなさ、その一つの細胞になりたくないわけ。だから退職じゃやってるじゃん。だけど餌がなくなったり飢餓状態になるとこう集まってきて、それで一個の個体を作って。 それでさ、上の人たちだけが次の世代を作った後は全部死んじゃう。だからでそうだから対バン構成なんだよこれはと思ったわけで、だから最初はさ、そのなんていうのすごくその一個のセルがそれぞれが非常にオートロマスに動き回ってると。だけどある時にそれがトランジションが起こってなんかコアオペレティブになってでそれをそのもともとさ、そのゲーム論でやってるような協調的な戦略があるとかそういうことじゃなくて、最初はコンペティティブなんだけどそれがコアオペレティブになるようなトランジションっていうのを起こってるじゃない。でそれをキャラクタライズできるかっていうことを考えたわけですね。
じゃあ部屋で質問はありちょっとテクニカル言葉とちょっっと僕は分かりにくい。
First of all, there's an egg cell. Egg cell is it right? Then it becomes fertilized and then become a baby, right? But at the same time, there's a placenta. I mean,
placenta.
Placenta.
Yeah.
Right. So the placenta and then baby.
Yeah.
And then my question to the lab last week was, which one do you want to be, like a baby or a placenta? And then most of the students say, I mean, the people say, okay, I mean, I want to be a baby, right? So of course, because a baby can survive and then can, I don't know, produce the next generation, right? But placenta is just an energy transfer interface, right? So once the baby came out, then it's useless and it just, it's dying out, right? So it's a cooperative agents, coming out from a single cell, right? So why this bifurcation happens? Like one of them becomes baby, and another one becomes the placenta, right? So this bifurcation mechanism is something that I wanted to understand. And then this slime mold is the same thing. When there is enough food, they just move around autonomously and then independently, right? But once there is no food around, and then they start to get together. And then some of them become a germline, and some of them become a somatic line, right? And then try to make individual, structures, and then the germline cells can, become a spore and then go to make a next generation, right? So that's why this cooperation is generated from the, competitive elements. That's kind of a very basic, biological question, but I looked into the papers, but I couldn't find the theory why this happens. So
yeah, no, it is. I mean, it's funny how if the agents are simpler, it's much easier to create structures that self-sacrifice for the greater survival of other pieces.
Yeah.
And I think again, it's one of those things which in our society, we're quite bad at doing. Although I would argue that in Japanese society, there's a stronger sense of kind of basically kind of keeping the social harmony at the cost of your own ambitions. Well, in America, for example, I mean,
maybe,
maybe America is an extreme example. UK, Europe is also quite a lot, but there's a strong sense of a lot of people just wanting to get their own, And maybe my sense is that there's less of that in Asia in general. Maybe not, but again, I'm relatively newcomer here. So if there's comments from 部屋で質問はありますか？コメント。
So my maybe you can go. Yeah. Or if you have so many.
Maybe you can go ahead.
Okay. Yeah. So I would think that the collective agency in my work is defined as a relocation. That's a very important word. The relocation of a predictive information from individual to the collective. So that's something that kind of the idea that I came up with. So that the single cell carries its own predictive structures. Means that current state determines future state of itself, right? However, a kind of autonomy, this is kind of autonomy, right? Because it's I decide my future state by myself. However, in a collective, the new predictive power can emerge only at the group level, so that the shift from individual control to the collective synergy, what I call is something that I call it, the shift to that kind of bifurcation that happened. I just explained, and then I think we can measure it with NTIC. Or then its story becomes I know because NTIC is a non-trivial information closure. And my purpose here today is try to explain this non-trivial information closure, right? Of course. So well, non-trivial information closure is that it's very simply defined that mutual information between the current state and the future state minus conditional mutual information of itself. Well, so the conditional mutual information. I mean, this is a long story, right? The interesting point is that the conditional probability is people can understand, right? So, what, really? Okay. So probability of A minus probability A when she happens is always positive because it's conditional is always limiting something, right? If you throw a dice, right, and then what is the probability of C? Number 1 or something. It's 1/6 if it's the correct dice, right? But suppose if the first one is like 1/3 or something. I mean, the first. I don't know. I don't think this is a good example, but well, so usually when you condition something, the event is always the less than the without condition, right? That's true, right? Conditioning is always decreasing the probability. However, the mutual information is different. So I didn't, come to realize this one, right? So when you have like just a probability, right? Then you have a Venn diagram to show that this is what the event of A, and this is the event of B, and then when A and B happen at the same time is this overlapping part. So the Venn diagram, people think it's very much, corresponding to the probabilistic, relationship, right? However, mutual information is different. So if you want to express mutual information in terms of Venn diagram, then the Venn diagram, the area becomes negative. Means that the Venn diagram metaphor doesn't exist in mutual information. So, but this is big problem, right? Usually the people think probabilistic event can be, represented by the Venn diagram. So you have like A event, B event, C event, and then what is the overlapping, and then you calculate this area, try to understand what's going on in this area or something, right? The conditional is always like overlapping, subtracted by this. Non-overlapping part. However, mutual information becomes negative. Mutual information minus conditional mutual information becomes negative, means that this area is a negative area. So it's very anti-intuitive that the area becomes negative, right? So the question is, what is the mathematical tool that we can understand this mutual, information relationship? So that's why I come to understand, and then our, transition from the single cell to the merged collective agency is something to do with this. So when NTIC, non-trivial information closure, becomes negative, is when this collective agency emerges. So that's my theory. Yeah. Then actually I tested 7 cases of different cell series of tetrahymena, right? And then this one is sorry. So it's complicated, but
I asked Claude Code to generate an explanation in simple terms, because I don't know what it is either. So would you like to hear it?
Yes.
Imagine a jazz band improvising. Yes, they hear the audience in the room, but the music that they create emerges from how each musician listens and responds to the other people in the band. The band becomes its own self-referencing loop. What the drummer plays shapes what the bassist plays, shapes what the pianist plays, which circles back to influence the drummer. The meaningful information that keeps the performance coherent is mostly being generated and processed from within the system itself.
That's nice explanation. But to me, it's understandable, but I don't know whether people can understand this. Well, I can. Yeah, I can do this. Yes, of course.
Do you believe that, in terms of mathematically speaking, then the more dimensions you add to your equation, the more probability that this emerges? So maybe the trigger will be a set of information in dimensions. Let's say you have a linear equation, but then you have another equation that intersects, and then you have a third one, and then, okay, now it emerges, because now we cannot use a simple diagram because our tools to draw that are not possible. But mathematically they are, because we have infinite dimensions to put. So it's like a multiple dimension problem with a mobile like not ceteris paribus. There's not existent.
No, but simply speaking, yeah, that's what I think. That's what I think. I believe, right? But what this one shows is when the NTIC becomes big positive, it's not so big, but 0.6 or something, right? So this is the early stage of when the cell is dividing into 8, but the very first 30 minutes, and NTIC is very high. Like this one is not more. Then it's going down like less than 0.1 is when the cell is moving around. So it's comparing this goes to the 0, and then when the next division time is coming, then the NTIC is a little bit going up. So the point is, so N5 and it's a coarse. I mean, it's difficult to explain, but coarse-grained degree of coarse-grained is changing from 1 to 5 to 10, means that how much integrating the state of the cell state over a step of time. Like each time that if you say this current time and the next time and next time, but when n equal 5 is like integrating from step 1 to step 5 and step 5 to step 10, step 5 to 10 to 15. So each how much degree that you can coarse-grain the state, but still you can compute the mutual information between successive state, right? Then what the NTIC is, and so if it's not so much depending on this delta t, means this NTIC is sort of independent of how much what is the unit of time step, that it doesn't depending on that. Well, most people don't care about this, but it's to me it's a big issue, right? So NTIC goes to approaching to 0 is something that I found when you have a bunch of cells, and then it's gradually NTIC goes to 0, right? So my thing is that the collective agency is when the future is written in the relationship, not in the parts of each cell, right? The relationship is a collective relationship that is where this autonomy, predictive power is shifting towards. So that the agency is not a binary property. It's whether there is an agency or not, right? It's more like a redistribution of a predictive responsibility from single cell autonomy to the collective synergy. So when I say synergy, means that if you know this and this know this, and then you can know much more than that. It's something that not single information source tells you what the entire system is, right? So why I came to understand this one is because if you have a heart, a brain, and kidney and lung, then if you put them together in a big buck, but you cannot make an individual. In order to make an individual, you really have to put some other thing. But what is some other thing? That's what I call synergy of the information parts, right? I mean, it's just a metaphor, but so that my kind of conclusion is that the pre-existing cellular agency it's going to facilitate multicellularity, right? So when you see the evolutionary time, then NTIC goes to approaching to the 0. That's where the multicellular system emerges. So the evolutionary tree what you have to do is measuring NTIC, along this evolutionary time. But then once NTIC goes down, then multicellular system emerges. Yeah, that's my big hypothesis. But that's something that I'm looking at this.
Do you think we can calculate NTIC from all of the Claude Code sessions?
Yes, that's exactly what I want to do. Yes.
Oh.
Yeah, but then this, so this Android I'm working with. So as you may know that I did some strange, for example, like if you ask him play the metal music, then he can do this, right? But so this is good. But then I said, I remember that Society of Mind is a big book by Minsky. I didn't, read. I didn't read this Blaze's book, The Intelligence, but I did the live thing. But Society of Mind is very important. So that instead of using, I don't know, but he calls the agent, we put LLM agent inside this, right? So that you can have like a different type of agents. But right now, so usually in an electric circuit that you connect this one with this and this one with this, but this time, all the, like LLM GPT or cloud determines, which one is going to be connected with this. So it's dynamically changing the connections.
It's funny, these kinds of diagrams of how everybody is connecting their workflows together. Yeah. Like I see so many like people, and it's like kind of like because things are going so fast, people are so frantic about, it's like, oh yeah, and then I have like all of the documents from this ingested into here, and then it goes here, and then I also in the morning I wake up and I do this thing, and then it clears my inbox, and then it, like, it's incredible what people are doing and how they're doing it with all these different tools. And like next week the tools are completely different again, and it's like you're constantly evolving, and these diagrams are just getting more and more complicated, or maybe somebody brings in a tool and then suddenly the diagram simplifies again. And it's like, it's very, that again, as a sort of software engineer minded person, this hacks my dopamine like heavily.
Okay.
I see. It makes it difficult for me to sleep.
I see.
No, yeah. So, but I say this as a warning, because like you shouldn't listen to what I say, because my dopamine is being hacked.
Okay,
you know what I mean? Like, so it's tricky.
Well, anyway, so this one is, if you know RAG LLM, this is a RAG LLM. But yes, please.
Yeah. So actually, going off of what Grisha said and this, I think that so I think like this framework, how they interact with each other is the future of where this is headed, at least in my opinion, because this, like right now we're hard coding this.
No, this one is a dynamic. So
actually,
so they send the query, and then there's if there's a adequate key, then they got the input from them. Which one is determined by the meta system report.
Interesting. Yeah, I think, like, to me, that's the future of where these multi-agent systems are heading. Because, like, for example, Amplifier, I went into because it's open source, you can see like how these multi-agents are interacting with each other. And for the most part, it's a mix between something that's hard-coded and something that's emergent from the LLMs itself. Now, Claude doesn't tell you how it works because it's not open source, right? But you can have some hard-coded something itself. But when I'm looking at these systems, like the most interesting question for me is how can you get these frameworks to be dynamic and responsive to the kinds of functions that we want to see happen? So I'm actually really curious to learn more about how you're approaching this problem.
Yeah, but that's exactly what we're doing now. So it's asynchronous. That's one of the most important things. So some of the modules is operating in this time scale, but some of the modules must operate in very fast time scales, right? So they do have to be asynchronous. And then also, usually they decide which query that you have to post. But this one, they always, inventing a new query.
It's funny. It's like extending. I don't know if there's this book like Thinking Fast and Slow, like when to operate in the two different modes and how to learn which parts of the system need to be fast and which parts of the system need to be slow. It's interesting. Wow.
Yeah. Well, So I know that. So something like, these are the name of these modules, and then how they are interacting with each other. This one is good. So it's dynamically changing all the time, right? But there's some kind of phase transition when the people come. So very interesting point is that, again, that I defined synergy and redundancy for each module. So synergy is once this module gets information A and B, and this output is more than A and B, then I call it, there is a synergy, right? So in LLM, that we represent each input and output in a high-dimensional vector, right? So what's going on here is that two vectors in high-dimensional space is rotating and then changing its directions. So we can calculate how much synergy that they have. But also the redundancy can be calculated because it's a cosine symmetry. I mean, if you calculate inner product, then you can understand how much cross the vector is. So once the vector is very similar to each other, then they have more redundant information. That's respect to the output, right?
So you're saying that we should increase the synergy.
Yes. But the interesting point is then we define this and then calculate it. And this is the redundancy and this is the synergy, right? And then interestingly, NTIC is redundancy minus synergy.
そうなんだ。
Yeah, so it's if I have a whiteboard, I can show
You
you
don't have
this.
to do that, sorry.
But the NTIC is redundancy minus synergy, okay? So
Higher the NTIC.
higher the synergy, and
Higher the
NTIC
synergy.
goes to minus, negative, right? So interestingly, when there's no human, right? I mean, so he can autonomously speak and do something, then redundancy is much.
I see.
It's
So that's
increasing.
related to open-endedness.
Yes.
With
Yes.
human interface interaction.
So when interacting with the human, then NTIC is going to negative. So I think there's something when AI is interacting with a human being, then it's more synergy is generated within the system. So that's something that I found was interesting.
Maybe Grisha, we should use NTSC to measure how open-endedness one system is.
Yeah, I mean, I think it's so interesting, and on one hand, so like I like to think about this and sort of like how this is going to pan out, kind of economically as well. Like if you can convince people that humans in the loop in certain processes are important, right? And you can quantify it, it's actually, again, something that could lead to good behavior, right? Which is like bringing in more humans into the loop to be able to, make decisions on, actually, we want more synergy in our systems. We want fast thinking here, slow thinking here. But on the other hand, you could also use this metric. And again, we have learned that as soon as you can quantify something, you can then benchmark it, maximize it, and then you may end up falling into the hands of a system which will use a single number to determine whether a human should be included in the loop or not. And so it's interesting to think about this. Like, and I wonder. Yeah, I wonder about that when I see this.
So, as a technical question, what are you measuring as the state here?
So every input is translated into the vector representation, right? So the only cosine similarity that we can calculate from them. Yep.
And what exactly is human interaction?
Human interaction is like when the human is interacting, then there is an input is coming from outside, right? So in a lag, in this vector store, that there are human, speech is input in there, right? And then those modules are taken from the human speech and then using them as an input to calculate the output. Yes.
Have you discovered certain types of interactions that reduce or increase NTIC?
We didn't do that. In order to do that, that's possible to calculate. But the thing is, this Android, has a camera in her eyes, and then also, they have a auditory mic. So, but everything is represented by the vector representation, which I don't know whether that's a good way to do this or not. Right? For example, like visual input if you represent it as a vector. And I'm not sure whether that's, well, of course on VLN, and we can go through it, and then you can output, then you can embed it into the vector space. However, I think the information is very much like, decaying out, right? Don't you think so? So I'm not quite sure whether this vector embedded, but that's the very basic of LLM right now. However, I don't know whether this LLM, the vector store is the best way to do this. So we're also thinking of, another way of embedding those vectors. Yeah.
So if you consider this, you're considering it from the system as the system just being the robot, but if we consider the system being the robot and the person, then what does this measure look like, you think?
How much percentage of the robot and human beings?
Yeah, I don't know how to answer that either.
Yeah, because it's difficult, right? But that's what we have to do. If all the time that the interacting with the human, and right, yes. We didn't do that. Yeah.
The other question I had was, have you looked at like yoked kind of designs where like it gets initialized to what a human interaction looks like, but then allow it to be by itself where there isn't an actual human interaction? So because you're having, there could be a confound of just having different inputs, right? Is it the human, derived, if you initialize it with those kinds of inputs and let it play, right? Will it stay in the sort of human interaction land, even though it doesn't have the human there or not?
That's an interesting question, but I haven't tried that. Yeah, but that's an interesting question. Yeah, I agree. Yeah. So this is the last 2 pages. So I think in Auto 3, the crucial environment is a human conversation partner, right? So when the human is present, the internal module reorganizes and the network state moves towards NTIC equals to 0. But this does not mean the system loses structure. It means that prediction is no longer localized in one module. It becomes distributed across the many collective dynamics, right? That's the point, I was trying to make. And then in the tetrahymena case, we observed that the same signature, when NTIC approaches 0, the predictive responsibility shifts upwards from the individual to the collective. So that usually that people wanted to call it, top-down causation, right? But so in both biology and artificial systems, NTIC equals to 0 marks the emergence of a collective agency, I think. And that the agency is not a part, but the coordinated system embedded in its environment. That's something that I was trying to make. Then, this autopoiesis, I really wanted to update the concept of autopoiesis, right? So that, but I know we don't have time, so maybe we can.
I actually think that was a beautiful conclusion. I think it's a really good stopping point to maybe share, like to basically, yeah.
Yes.
Okay.
So this is like agency emerges at the boundary between the system and the world. That's so. I think the agency, you shouldn't think by it per se, right? Really have to think about the interface between the world and the system itself. So that's where that you can find agency. That's my working principle. Yes. Well, thank you so much.